Well, hello, and welcome to Mixed Operations Part 1. And I've got an example sitting here, and you can see why it's called mixed operations. Here we have a fraction or rational expression, and we're going to add that to this one. But before we do anything, we have to divide this rational expression by this one. So really important here is that you remember your order of operations, okay? In other words, BEDMAS, because it does come into play. So you got to remember that if there are brackets or exponents, those come before division multiplication. Well, there isn't any here, but there certainly is division and multiplication. So I've got to do this stuff first. And then when that's all done, then looks like I'm going to add some fractions. So first thing I've got to do is this division. So I'm going to leave this fraction out in front. Okay, just leave that guy the way it is. Deal with that later. And I'm going to add to it the division, the quotient, when I work out these two fractions here. So how do I divide fractions? Well, I'm going to do two things here at the same time. I am going to switch this to multiplication, and that means I have to flip this second fraction, right? You switch the division to multiplication, but in order to make that work, you have to flip this over. So you can see I'm putting x plus 6, which was on the top, is now on the bottom. And then I'm going to take this thing here, and when I write it on the top, before I do that, I'm actually going to change it into its factored form. So it looks like I need an x times an x. Then I need a number times a number that makes negative 20 that adds up to negative 1. So I'm thinking negative 5 and positive 4. All right, now I'm ready to go ahead and do some simplifying here. So let's just put brackets around this so we can think of that as a little bundle. And I can see, hey, this bundle here on the bottom is exactly like this bundle here on the top. So I'm going to cancel those. So look at what I've got left now. I have x plus 5 divided by x plus 6. And I'm adding to that this fraction over here, which, wouldn't you know it, it has the same denominator. So I can go ahead. I don't even have to convert these to have the same denominator. It just came out that way. So I can go ahead and add them together. So they're going to have the same denominator of x plus 6. And on the top, I have an x plus another x. So there's two x's. And then over here, I have a plus 5. And I'm going to add to that a negative 5. So those just cancel with each other. And this is my answer. So the only other thing to do is to list some of the restrictions. So x cannot be allowed to equal. So now I got to go through the whole thing, even those things that got canceled, and make sure that we never allow the bottom stuff to become 0. So clearly negative 6 is not allowed, okay, because you don't want to have this x plus 6 turning into 0. So what else do I have? Oh, we canceled it, but at one time negative 4 was a no-no, so that's always a no-no. And let's see, anything else? Well, remember this stuff here? There was a time when this stuff was on the bottom, right? This here is the same as x minus 5 times x plus 4. Well, when it was on the bottom, 5 and negative 4 were bad. So that 5 is still considered restricted, even though it got flipped to the top. But up here, it was on the bottom. So it's part of our restrictions. So that completes this first example. Okay, now what I'm going to do is we're going to clear the screen, and we're going to introduce something called complex fractions. I'm going to show you how we deal with complex fractions. Okay, so kind of a part 2, if you will, of today's stuff. Complex fractions means you have a fraction within a fraction. For example, what if you had something like this? 1 over x and all of that over 2. You see how I've got a fraction within the fraction? Here's how we deal with complex fractions. Easiest way to get rid of all of this mess is to say, you know, I'm going to multiply the top and bottom by something that gets rid of this fraction. So I'm going to focus on this denominator. Why don't I multiply top and bottom by x? I mean, as long as you multiply the top and bottom by the same thing, this is fine. So I'm going to have 1 over x times x, or if you like, x over 1. So these x's would cancel. And so I end up with a 1 over 1. So that's just going to be a 1 on the top. And on the bottom, I have 2 times x. So guess what? There is my simplified fraction. So we're going to do one more of those, a little bit more complicated, and then we're going to come back with some more of these complex fractions. So let's clear the screen so we have enough room to do our today's last example. So here's what we have. 1/3 plus x on the top of my fraction, and underneath that I have 1/4 minus x. So I go, okay, let's get rid of the fractions within the fraction. So what I'm going to do, I'm going to multiply the top and the bottom by something that is divisible by 3 and also divisible by 4. And the smallest such number is 12. So I make sure I do it to the top and bottom. Okay, so what's going to happen here? Well, on the top, I'm going to have 12 times 1/3. Okay, so that's, actually, let's write the whole thing out so you can totally see what's happening. So we have 12 times 1/3, and then we have 12 times x, and that's positive. So that one's pretty easy. That's just 12x. Okay, and then on the bottom, I have 12 times 1/4. Okay, so 12 times 1/4, and then 12 times negative x. So that's going to be a negative 12x. Okay, so how does this help? Well, 12 divided by 3 is 4. So here's what the top becomes. That's not too bad. And the bottom, 12 divided by 4 is 3, and then I have minus 12x. There is one more thing that I could do, although in this example it doesn't really get me anywhere, but I could factor out the common 4 on the top. So that leaves me with 1 plus 3x. And then on the bottom, I could factor out a common 3. So that would leave me with 1 minus 4x. And there it is. That's my final answer. Okay, so that's nice and simplified. And that's where I'm going to stop for today. We're going to come back with some more complicated, complex fractions.